Okay, we can start.
Hello, everyone. Thank you for joining us today for Vaccine Cards and Predictive Models for Vaccination, brought to you by Trusted Pandemic Technologies at the MIT Media Lab and Auto ID Labs. We are excited. We have a great group of speakers for you today. And now I'm going to turn it over to Professor Ramesh Raskar, who will introduce you to all the wonderful people you're going to hear from. Thank you.
Thank you, Rachel. I'm Ramesh Raskar, Associate Professor at MIT. And today we have a wonderful conversation on two main topics, new types of paper credentials for improving the flow of vaccination, as well as new tools such as agent-based simulation toolkits to have a dashboard view for predictions of the spread of the impact of vaccination, testing, and other mechanisms for controlling this epidemic. And in the second half, we'll also hear from Chris Doshi and Asif Dar and Vinay Gidwani, leaders in various organizations that are creating such solutions. So in the first block, it's myself, James Smalls from IDEO, Anna Lizinskaya from Brown University, and Vitor Pamplona from PathCheck Foundation about protocols without the red tape. Soon after that, we'll have Balaji Krishnamurthy, Ayush Chopra, and Thomas Kingsley talking about agent-based simulations. And then finally, Chris Doshi, Asif Dar, and Vinay Gidwani, experts already working in vaccine rollouts. So let's talk about paper credentials, a protocol from MIT SafePaths in partnerships with IDEO, PathCheck, and also Brown University on how we can use an encrypted user journey and still create a data-rich vaccine monitoring platform, not just for verifying that you have been vaccinated, but also to improve the ability for phased eligibility, two-dose visits, reporting of side effects, and credentials. So more information is on our website at pandemic.mit.edu. And also join our Slack channel at tiny.cc/pathcheckslack. And the reason why we could, vaccinate in 1947 5 million people in 2 weeks, one could argue, was because there was no digital technology and we were not obsessed about capturing personally identifiable information. So how can we create a similar experience, take the technology out of the experience of an individual, at the same time create enough triangulation so that we can understand how the vaccine rollouts are coming together. So myself and Sanjay Sharma and Lazinskaya have been working on this protocol that could augment the existing CDC, VSafe, VAMS, and IIS systems, either by using paper credentials or by using apps. And for these four major problems we have, eligibility, dosing, entry permits, and health monitoring, there are existing systems at the federal and the state level. The question is, do we have an opportunity to augment such cards? And working with IDEO, we think a new human-centered design approach can dramatically improve the vaccination rollout workflows. And the key idea behind this is stickers and QR codes that a user will collect through their journey. And we call them coupons or badges. And the coupons are given out almost like a gift card, given by either the employer or the city, or comes to you in the mail that simply says you can use this coupon to get vaccinated. At some point, the coupon gets activated, and then the user goes to a vaccination site where they will get a badge that validates their status, and eventually they would get few more stickers that as I will explain later. So we do want to think about all four stages of the user flow: the eligibility, the vaccination itself, its verification, and long-term monitoring. And for these four stages, we think QR codes like coupons and badges can be used by employers and vaccinators to interact with the user as shown in the top row. And in one extreme of these paper credentials, a user would never have to deal with technology at all, no websites, no apps, and so on. And they would get a physical card, a paper credential card in the mail or from their employer or from their city hall that pre-certifies them for vaccination based on their eligibility. And then they would go to a vaccination site to get the badge. Those are the kind of two main aspects of these credentials. And later on, they can also use it post-vaccination for entry passports or for monitoring long-term health. So our cryptographer, Anna, is going to come and talk a little bit more about the protocol itself. But the basic idea is that this pre-certified gift card or the coupon is given to everybody in advance, which can be only used at a particular city and a particular phase of vaccination. And the badge is given out with dose information encoded in it. The assumption here is that there's some central authority that's going to provide this offline credentials so that there's a message in the clear as well as a signature of the message that's certified, in this case, let's say by CDC, some kind of a central authority. And we have one workflow where the username and date of birth can be part of the credential. And then we have another flow where users may want to stay anonymous and only the hash of the information is used for this. So what are some main differences with respect to the workflow today, which is we think we should just send out these gift cards, these coupons right now to everybody. All the 330 million plus people in the country should just get a coupon right now, which is digitally certified, is tamper-proof, and has pseudo identifiers. Second proposal is that let's not use name and date of birth because that can impact vulnerable population. It creates unnecessary friction. Many governors have already told CDC that they will not use a WAMP system. And then employers are telling the governors that they will not share PI of their employees at the state level. So we can get rid of this complexity. And as you can see on the top right, if we can avoid the PII, it also simplifies the exchange of these data systems with each other. And then any long-term side effects that we need to monitor and report can also have a KYC, some kind of a know your customer, a verified upload to CDC as well. So the friction that we have, the challenges that we have that we see in the top row in these 4 phases, the anxiety of whether you're going to get the dose or not, when exactly is your slot, the scramble we have on websites for scheduling, we think a lot of that can be eliminated through these coupons, through these gift cards. Second, at dosing, there's a lot of manpower that's required to take individuals at the sites, and much of that can be eliminated by doing this work in an offline manner. Especially as we start thinking about pop-up sites for vaccination, this will become critical. And then similarly for entry permits and for monitoring. Of course, there are many questions. Is this only for physical paper cards? No, as Chris Joshi will tell you, this can also be delivered over SMS or it can come in the email. But the whole idea is this is an offline experience for an individual. Second is, how can you give somebody a vaccine without knowing their PII, and how can you contact them? And there's straightforward ways to deal with that. Is this a health passport? No, it's much more than that, because it's for a full user journey from eligibility to dosing to the first, second dose coordination, all the way to health monitoring. What do you do if the card is lost? How do you deal with fraud? And so, of course, we have looked at all these issues. So please take a look at our website. So with that, let me hand it over to Anna Lizinskaya, professor at Brown University, and she's going to tell us about the protocol behind this.
Hi, everyone. Welcome. Let me share my screen. So are you seeing the presenter view or are you seeing the correct view?
It's the presenter view. That's perfect. Yeah.
Oh, you're seeing are you seeing the
full view? It's good. Yeah.
The full view. Okay, good. So I'm just going to give you the cryptographic view of the vaccination credentials that we have proposed. So first of all, let us talk about who are the participants in the vaccination in the process. So there's the issuer of the vaccination passports. For example, it could be the CDC. There is the distributor, the entity that's in charge of distributing the vaccine and also allocating the doses, and that's a local entity, for example, a city hall or hospital. So it receives a certain number of vaccination slots, appointments, doses, whatever you want to call them, and it needs to distribute them. So then there are the people who are getting vaccinated, the vaccination clinics, like such as a pharmacy. And then once you go through the whole process and you get vaccinated, now the goal is that you should get a document that says that you've been vaccinated, that you can go and present to a verifier. So that's whoever needs to verify your vaccination status. For example, a venue such as the Fenway Park or the Boston Symphony Orchestra. So here are the phases of the process, the way that we think makes sense. There's some setup phase where we all, get together and figure out what these credentials are going to look like, what kind of infrastructure is needed, where all of these decisions are made, and all the entities get what they need to run the protocol. Then there's the phase of the coupon distribution. So if the distributor thinks you're eligible, you get a coupon. Then there is vaccination phase 1, where if you get a coupon, you get the first dose of the vaccine, and you get a badge, something that we call a badge, which is basically a document attesting to you having been vaccinated, having received 1 shot of a vaccine. Then there's vaccination phase 2. If you have a badge that says you received the first shot of a vaccine, you're presented, you get the second shot of the vaccine, and you also get an updated badge that says now you've gotten 2 doses of the vaccine. Then there's a phase, now you have a badge, you can talk to a verifier who will verify your badge and give you access. And then we also have ideas for how your information can be, how your badge can be used for you to transmit helpful information, say to the CDC or to some medical researcher, to say, okay, I've been vaccinated, I have a badge, here is my experience with the vaccine. And you can authenticate this information using your badge. Okay, so what are our security considerations? First of all, we don't want coupons and badges to be forgeable. So somebody who doesn't have a valid coupon should not be able to just make one up. Somebody who doesn't have a valid badge should not be able to make one up. Non-transferability of badges. If Alice has been vaccinated and has received a badge saying that, she cannot just let somebody else use her badge. It has to be tied to Alice's identity. And then another consideration that may or may not make sense, that's up for discussion, is do we want coupons to also be non-transferable? If Alice has received a vaccination coupon, should she be the only one who is able to take advantage of it? There are some pros and cons. That's up for discussion. Our privacy considerations are, the number one is that there shouldn't be a central verification database. So whether or not you've been vaccinated is, your vaccination status. It's none of anybody else's business. When you want to prove that you have been vaccinated, you can prove it to a verifier, but there isn't a central verification database where anybody can go, your neighbors, friends, cannot just go to a central database and find out if you've been vaccinated. So there's no central database and a user-centric verification. Each person can show or not show his or her credential. And then another desirable privacy consideration, and we can argue the pros and cons of building it into the system from the ground up or not, is unlinkability, so that you can go and show the same credential, but 2 different verifiers are not going to be able to figure out that it's the same person, so they cannot track you wherever you go with your credential. So I showed you security considerations and privacy considerations. Let me now tell you a little bit of our usability considerations. So our number one consideration in this design is to empower users who can only use paper-based credentials. We don't want to require that in order to take advantage of this system, you need any special devices. No, we want credentials that fit on a piece of paper that you can just put in your wallet and use. Now, if you have a device, if you have an app, maybe we can give you the same credential, but with more features, with more ways of using it, with more interesting ways of using it, with potentially better privacy features. So that's great if you have an app. But if you don't, you can just have a paper-based one. We also want it easy for the verifiers to verify your credentials, so that they don't have to like be connected to the internet, running special devices. That would be too much. And finally, it's nice if you can design the coupons, which is about distribution of vaccines, and badges. They don't have to be intrinsically part of the same system. We can decouple them so that qualification for vaccination doesn't have to be part of the same process as delivery. Okay, so with that, let me tell you what our answer is. But first, let me tell you a little bit about our main tool. So our main tool is cryptographic signatures. So that is just amazing math. If you're familiar with cryptographic signatures, then you must agree with me that it's amazing. If you're not familiar, you're in for a treat. It's just so cool that you can do this. It's a mathematical discovery. It's won its inventors prizes and glory, and it's totally worth learning about. Will take more time than I'm authorized to spend right now. But what it does is it makes it possible for right now, as you're watching this talk, makes it possible for your browser to make sure that it's actually connected to YouTube and not some other site. So you're not being spoofed. If you're doing an online purchase, then you know you're connected to Amazon.com and not somebody in the middle. So that's what makes that possible. And it consists of an algorithm that generates keys, an algorithm for signing, for authenticating a document, and an algorithm for verifying a digital signature. And you cannot create a signature on a new message without access to the secret key. So with all of that in mind, this is the same slide you've already seen in Ramesh's presentation. This is how our protocol works. This is one just to give you a flavor. So in our protocol, what is a coupon? A coupon is a signature of the issuer on all these information. So it says, this is coupon number 37 out of 5,000 in Springfield with vaccination phase 1B, and your job as a teacher. So as a teacher, you get a coupon like this. It's unique to you because it's 37 out of 5,000. The other coupons have other numbers, like 38 out of 5,000, etc. So you can see that this coupon in this suggestion, the coupon would be transferable. If you get a coupon, you can give it to somebody else because it doesn't have your name in it, but maybe you're not motivated to because you actually want the vaccine. So this information is signed, so you cannot just forge a coupon. Now you go and you get vaccinated, and then you get a badge. Now the badge has a little bit more information. Now the badge says, this was your coupon. This is the kind of vaccine you got. It said you get Pfizer. This is your first shot. And this hash of passkey that, so what does that mean? Passkey is the information that is actually personalized to you. So that's where your name and date of birth is and another random salt. And that's hashed so that by itself, it doesn't reveal who you are. So that is the information that's in your badge, and then it's signed again by the CDC. Note that the CDC here doesn't actually even know the names of the people who are being vaccinated. So even if it wanted to create a central database, it couldn't. Anyway, so now you can take this badge and you can show it to a verifier, and you can show to the verifier that it is actually your badge and not somebody else's, because you can show them what's inside the hash. You can show them your passkey that has your name on it, and then they can verify that it's you by, for example, checking your ID. So that's our proposal, and notice that all this information, that this is not that much information. So it all fits in just a QR code that can be printed on two sides of a little card. Actually, it's a card that folds. So there's anyway, you know what I mean. And it can fit in your wallet. So with that, I'm going to cede the floor. That's the end of my my presentation on the cryptographic view of our vaccination credentials.
Thank you, Anna. And I think the point is, it's worth emphasizing the point that theoretically the whole experience can be offline from a user's point of view.
Exactly. So the user just gets a little piece of paper when he or she gets vaccinated, and then shows that same piece of paper to a verifier. And nobody needs to be connected to the internet, because in order to verify your badge, the verifier just needs to locally have the signature verification algorithm and the verification key stored on their device, and then everybody's good to go. Thanks. That's a very important clarification.
So on that note, let's invite James Smalls from IDEO. And IDEO and the team has been working with us at MIT and PathCheck for the last several weeks, thinking about what this offline experience could look like for a user. So James.
Thank you, Ramesh. Yeah, it's been really wonderful that there's been such an emphasis on analog and offline experiences here. As much as, being an interaction designer, I love the influence of technology here, and I'm super appreciative of the rigor that's gone into the technical back end. It's been really great to be able to work on this project and be considerate and mindful of these human experiences, and being able to really think critically about the different people who are going to be affected by what we're proposing. So, when we're designing this and we look at the people that we're building for, the user, the vaccine recipient, is often who we anchor around, and we want to be able to design for them to make sure that we're creating something that works for people with varying levels of technical comfort and literacy, people who may belong to vulnerable populations, and so on. So what we have right now is already making great strides toward that effort. And while we're anchoring around the vaccine recipient, we can't design a good experience for them without considering all of the other people who they interact with in this journey toward being vaccinated. So when we look at what already exists,
James, do you want to
something?
James, your
Sure.
slides are not up yet, so.
Oh no, sorry about that. Okay, how about now?
That looks good, yeah.
Okay, so you didn't miss too much. The previous one was just kind of looking at who some of the people are that we're considering in this design. So again, considering all of the people who are interacting with the vaccine recipient along the journey. So we begin by looking at what already exists. We have a vaccination card that people may be familiar with already, and it works pretty well. But there are some pieces here that we can use to augment this experience, to provide richer data, and to allow some post-vaccination experiences that can become really important in this scenario. And then again, while we're doing this, we're being mindful when designing these physical artifacts that we're being considerate, again, of this wide array of technical comfort and literacy that we have. So we're leveraging these QR codes, but we're trying to embed some information in them that allows them to be human legible. So including some symbols that live inside, obviously labeling them. But this is just the first step. We can add additional visuals and augmentations around the outside to make sure that the passkey, the badge, your status, and your coupon are all very distinct from one another. The other important thing about the materiality and the layout and the physical makeup of these cards is the folding that Anna mentioned. And while that allows you to be able to carry this thing in a more compact form, it also provides some level of privacy in the physical piece. So you can imagine if you're going to a health authority and you're getting a second dose, you're going to want to show very different information than if you're going to a concert and you just need to verify that you've been vaccinated. So the makeup of this card allows you to do exactly that. Some of that information lives on one fold, other information lives on another fold. So you're able to protect information that you don't want to show at any given time. And then it's also reproducible. This thing is able to be printed. It's formatted from an 8.5 by 11 sheet. So if you damage your card, or if it makes more sense for you to print one at home, you can fold it in half, create the trifold, and you've got something that you've created from your own printer that matches the format of something you would receive in a direct mail. So where do we go from here? To the left, you see the outline of an application that Ramesh will share with you, which is intended to be the experience that the health administrator or the vaccinator uses in order to track batches, verify coupons from users who are coming into their facilities, and then to produce the badges that they will carry with them on their cards when they need to come back for a second dose or go into a venue or a workplace, like we mentioned earlier. The other part of this is just the constant iteration that I was kind of mentioning before. How can we make the QR codes themselves more legible to humans while maintaining their ability to be machine read? How can we position them on the card within the constraints that we have physically in order to ensure accuracy in scanning and to make sure that you're not spending those extra couple of seconds picking up a scan that you didn't intend to do in the moment when someone hands you a card. And then retaining what works about the existing card. We don't want to completely break people's mental frameworks. We want to be able to have something that feels familiar, but adds just enough in order to kind of further the efforts of this whole group in ensuring that we protect privacy and we create some usability for people in the post-vaccination experience. And that's it for me. I'll turn it back over to Ramesh. Thank you.
Thank you, James. And it's a wonderful collaboration with IDEO to see how we can create this analog experiences for the user, at the same time, make this a high-tech solution because we can triangulate from various touch points of the journey of the user while maintaining privacy. So let me transition over to the other aspect of it, which is how do you actually create an experience for everybody else? So the user might be carrying an analog card, but everybody else needs to scan it in particular way. So Vitor Pamplona and team at PathCheck have already built, in coordination with IDEO, have already built out that experience. And so I'll show you the concept video for this of how this would be used either by a person who gives out the coupon or at the vaccination site and so on. So, the vaccination site has to be authenticated, in this case through a login, Vanguard Health, and they would, on the day of vaccination, they would make sure that they know what dose they're giving out today. So they're giving out a dose from Pfizer in a lot X3D 621 at this location in Cambridge. As done, they can confirm that this is all good, and then they're ready for the day. So they come in for every user. They can record the dose. First, scan the patient eligibility coupon. This is what we showed, I and Anna showed earlier. So they would scan the coupon, activate that, make sure it has not been used by anybody else, and it's for the same phase and so on. In this case, it was for a firefighter, in the city of Cambridge, for example. You're ready to administer the vaccine dose, and once that's done, the vaccine site can print a passkey or the badge on the spot. So to access the badge, the pharmacy will have to get the certificate from CDC or some kind of a central authority, and it can all be done through this app. So imagine pop-up sites that don't require, computers and full-fledged internet access. All of this can be done with a few clicks. And you can either print the badge with a $30 printer, or you can also SMS it back to the user, as Chris will show you. And then, at the vaccine side, other places, if you go back and you have health symptoms to report, in the same app, the caregiver can start recording all these interactions. And because we know exactly which user it was, because we have their coupon and their badge, this is type of a KYC. The user is already authenticated in the system, and anonymously you can upload this to the vSafe or VAERS, or to the dosing company, in this case Pfizer or Moderna. And then the experience continues. If you want to record the dose for the second dose, or in this case is simply for scanning for verification that this is John Doe who has been vaccinated or not. So it's a selective disclosure of their status as well. And then when they come back for second vaccine dose, we know exactly which dose they had taken. It was Pfizer, so it should be given Pfizer when they come back. And as James talked about, these badges have different shapes. The complete badge versus the status versus the passkey. So the stickers can be placed at the right locations on those on the vaccination card as well. And again, at entry points and venues, this can be used offline as well to confirm that this user has been vaccinated. And for this, the verifier does not have to be online. So it's an offline experience for both entities, as long as they have the public key to validate the signature. So hopefully that gives a very good idea of how we're thinking about these flows and these experiences. And a pretty big team at PathCheck is putting together many pieces of this. So please join the Slack at tiny.cc/PathCheck Slack. And although I'm not showing today the other work that's going on at PathCheck, you can download the user-facing app itself. So although it's an end-to-end analog experience, you can also replicate the same experience in the app, and the app is already in the Google Play Store. So with that, let me hand it over to our next panel, moderated by Tom Kingsley, MD, PhD from Mayo Clinic, and he'll be speaking to Balaji Krishnamurthy, PhD from Adobe, and Ayush Chopra, who's a scientist at MIT. Handing over to Tom.
All right, thank you very much. I think Dr. Kanasti and Ayush are going to present first, and then I think we moderate. So would you guys want to start off with your presentation? We're really looking forward to hearing.
Sure. I'll start sharing the screen then. Can you see my screen?
Yes, looks good.
Yeah.
Great. I think Balaji will start the presentation.
Balaji, I think you're on mute.
All right. Okay. All right. Thank you. Yeah. Thank you, everyone, for joining our session. I'm very excited to present Deep ABM, which is our tool for simulation to support the scenarios that will lead to our COVID-19 recovery. And this is a joint effort from a bunch of people from Adobe and MIT. And again, I'm pretty excited to talk about it. So let's get right down to it. Can we go to the next slide, please? So over the last 1 year, as we have been passing through the pandemic, we've been assailed by a series of what-if questions, both from an individual level as well as from a policy level. For example, there are many questions that still remain, right? what if we were to reopen the schools in the next 100 days or the near future? We have a 2-dose vaccine. So what if we delay the second dose in favor of vaccinating a larger number of population with a single dose? What if people, after getting cooped up inside for so long, after getting their initial dose of vaccination, start interacting a lot more and going out? What kind of effects it would have on the COVID-19 spread, right? So these are all questions that we need to answer. And before vaccines, we had this question about whether we should prioritize a faster but less specific test in favor of a test that has a higher turnaround time, but is much more specific. So the key challenge in estimating all of these is that the phenomenon that we are trying to model is very complex, and we really need very good tools to make very fast and better informed decisions. Right? That's the need of the hour. Maybe we can go to the next slide. So to drill down deeper, let's just take one question, which is the case of whether we should go for whether policy-wise we should prioritize a faster test versus for a more accurate test. So the intuitive answer could be that we should go for a more accurate test. But if we actually do a modeling under the assumption that we are looking at a population of individuals who have various behaviors and who are kind of heterogeneous in their behavior, and you take into the account the fact that there is a time lag between the time the test is administered and the test results come out, and there is a lot of interaction between them, and you put all of those things in and you model it, then you come up with the kind of results that we have shown here, where administering tests that are having a much faster turnaround will have better outcomes for the whole population. So the answers to these questions are kind of non-intuitive, and it requires us to use modeling frameworks that are able to take individual people as agents and model all the effects that are going around them, and also take into account the various interactions they could have. So such models, such family of models are called agent-based models. And those models essentially enable us to simulate the action and interaction of multiple agents, and also be able to predict the population level effects. Can we go to the next slide? Right. So agent-based models are a really cool thing. And the graphic here is something that from an article on Wall Street Journal about agent-based models and their good properties. So you take each individual in the population as an agent who has a certain amount of connections, and then you can model the effects of how the information, or in this case, virus, transmits among the population. Right? So it is capable of representing interactions in heterogeneous population. It can support time varying actions, and pretty complex phenomena can be modeled here. All good, but traditionally ABMs are a very computationally expensive to run, and they're also very hard to implement and maintain, because it's kind of difficult to do it in a normal standard way. And there is a lot of parameters and configurations that one needs to take care of, and traditional ABMs are really hard to configure and parameterize. However, if you really want these tools to work, then we need to make them make ABM scalable, efficient, and high performant. Right? Next slide, please. And this is exactly what the MIT Adobe team has done. Right? So what we have done is that we took ABMs and reimagined them in modern machine learning frameworks. So what we have by doing this, what we have done is that we would take the local interactions of agents in an ABM and modeled it through what are called graph convolutions, and implemented them on using tensor calculus. So once we are able to do this, we are able to achieve a large scale. We can support large agent populations, which are larger than 100,000 agents. We can utilize GPUs or graphics processing units, which are very efficient computational units, and be able to get you results in a very near real-time fashion. And we are able to also integrate diverse data sources, which are necessary to model such complex phenomena and give you very highly performant models. So by using this ABM tool, we are able to quickly evaluate a large number of diverse scenarios and be able to come up with good decisions. Next slide, please. Right. And in particular for the COVID-19, what we have done is we took our ABM framework and we have added a whole bunch of configurable features to specifically support COVID-19 simulations. So the variables fall in COVID-19 simulations fall under three broad buckets. One is about how the agents or the population is interacting among themselves, and which we model it as interaction networks. The disease dynamics, about how the disease progresses. And the third one would be all the interventions that we could possibly have, right? In terms of interaction, we model the interaction between people in three layers. One is that people interact among their households, and there is interaction with the people in the places of work, which is the occupation. And finally, there is a bunch of random interactions that happen as people go through their day, right? And for disease dynamics, we have ability to do a very granular stages of infection. We know that the dynamics of the disease is stratified by age, and we have taken care of all of that, taken account of that in the model. And we also have support for modeling diverse strains. Like we now have a new strain that is coming in, especially in Europe and other areas. We could model all of that. And in terms of interventions, we have all of the current things that we have, which is quarantine, notification of exposure, various forms of testing, vaccination, and so on. So these are all, so we have a very configurable tool, which is, which you can use it at a programmatic level, as well as a modular and an intuitive UI with which we can experiment with it, right? And next slide. Yeah, so I think I'm going to hand it over to Ayush, who can walk you through a demo of what our tool does, specifically for COVID-19, and then I can come back and wrap it. Ayush, you can start.
Thank you, Balaji. Hi. So to make it easier for the real experts to iterate, make quick decisions, we augment deep ABM with a simple and intuitive interface that can help seamless experimentation. Basically, our goal is fourfold. We wanted to add modularity to the system, so through a plug and play interface, so that you can customize experiments for the different kinds of networks, disease dynamics, and the kinds of interventions you would want to try out. We wanted to bring in granularity, so that experts can have fine-grained control over various social, behavioral, and clinical assumptions that parameterize the agent-based model and our interactions in society. And we wanted to do this with a lot of flexibility, so that we can have fast experimentation, iteration, and hypothesis testing, as well as sensitivity analysis. And our tool, the efficiency of our tool makes it possible, since we can run results in real time on large agent population. So I'll now walk us through a real interactive demo of how the tool works. So this is the tool dashboard. So the deep ABM window consists of a setup on the left and an option to then run experiments. So have a very modular experience. We allow experimenters to specify the dynamics for the specific kind of agent population they want to work with. So first we import the population dynamics, which can be a simple CSV, which specifies what two agents look like and how they interact with each other. We can then specify the specific properties of the infection that we are modeling. These are usually clinical parameters, which an expert may want to change based on the specific kind of experiments. Next, we can select one or many different interventions and have granular control for each of them. In particular, we support 4 interventions. You can do exposure notification, where you can specify what would be an assumed adoption and compliance rate to model social behavior. We can specify symptomatic testing, which may involve using RT-PCR or antigen tests. we can specify parameters for vaccination, as well as for different kinds of rapid point of care testing. For vaccination, we may want to simulate what happens if we do double doses on schedule, or if there is a delay in second dose. Let's choose a scheduled double dose for the moment. We can also choose and experiment with what if the efficacy of the single dose vaccine is different. So we know that the efficacy of the 2-dose vaccine is 95%, but what if the efficacy of a single dose is 90%? And then we can also tweak and study the effect of changes in daily administration rates of vaccines. So let's run a simple experiment. The deep ABM tool runs this experiment in real time and helps us visualize the cumulative infection, mortality, and hospitalizations over a period of 6 months through the simulation. Now, we may want to tweak and study the effect of granular changes in parameters. For instance, what if we increase the daily administration rate to 100%, to 1% of the population per day? And we also have this option to do persistent comparison so that each additional experiment can be compared with all previous experiments we've run. So when we rerun this experiment, we see that, as expected, there is significant decrease in mortality, hospitalization, and cumulative infections on increasing the daily vaccination rate. While this is very useful, we realize that in ramping up vaccination rates can take time, and there is a short ramp up time. So in the meanwhile, we want to ask this question: what if we use additional intervention strategies to maximize the effect of our current vaccination load? So in this rate, there has been a lot of discussion around using random point of care tests to identify pre-symptomatic agents and quarantine them beforehand so that there is decrease in viral spread. So we simulate the study at our current experimental rates, at our current vaccine efficacy rate, and we can run a new experiment just by changing a single parameter. And the purple line represents the setup where we augment the daily vaccination rate in our current setup and augment this with random point of care tests. And we realize that there is a significant decrease in mortality, deaths, and hospitalizations. So we can use the deep ABM can help us consider that using random point of care testing can be a good alternative to augment our current vaccination strategies while we ramp up daily vaccination rates. So we've used this tool to study a lot more other parameters as well. So for instance, the scientists and clinicians and health experts at Mayo Clinic, Arizona, and Harvard University, we collaborated with them to study what if we delay the second vaccination dose. And we realized that under the current parameter configurations, delaying second dose in favor of the first dose can lead to a nearly 20% reduction in deaths. Apart from clinical considerations, deep ABM can also be extremely valuable for social messaging. For instance, the last year has been hard on everybody, and we're eagerly waiting for vaccination so that we can go back to our daily lives. So we wanted to study what if people increase interactions immediately after taking the first dose. To analyze this, we studied the effect of 2x, 4x, and 8x increase in random interactions after the first dose is administered. And we realized that there is a chance of significant increase in deaths, nearly 2x, even with continued vaccination. So vaccination parties will have to wait. So these are important messages which government and policy making departments might need to consider so as to ensure safe recovery from the COVID. Back to you, Balaji.
Thank you, Ayush. So this tool, the deep ABM tool, has a lot of potential, not beyond COVID, also in multiple areas. For example, in public health, you can use the deep ABM to find out the effect of personalized notifications, what's the effect of knowledge dissemination, and so on. And certainly will be useful in other epidemics that will follow. In terms of economics, you can look at deep ABMs for modeling how the economy will recover from a shock like the current one. You can also look at ABMs for fiscal policy, monetary policy, and other such economic questions. In terms of business, you can look at, you can use the deep ABMs to look at the effect of social interactions, to measure what would happen with personalized offers and how to conduct more effective brand messaging campaigns. Right? And one more good thing about the deep ABM work that we've done is that since we have fused a machine learning framework along with ABMs, it allows us to do learning on top of ABMs and be able to adapt behavior from one agent community into another. So plenty of opportunities are available, and I'm really hoping that we can collaborate with all of you to take this tool and put it to good use so that we can get back quickly to our lives and take the key policy decisions based upon proper simulation and considering all factors, right? So, so next slide, please. So, so again, an invitation to reach out to us and collaborate with us. You can use a QR code over there, or if you prefer a human readable thing, then we have our contact details right here. Thanks a lot. And over back to you.
Yeah, I want to thank you, Balaj and Ayush. This is absolutely brilliant work. Couple questions for you guys. So when you were approaching this, you know, one of the things with ABM models is that they're typically slow to build. Looks like what you guys have done would allow for kind of fast iterations and answering questions quickly, which we've realized from a healthcare perspective, public health perspective is so important. You know, one of the things that you said that this model allows is modularity. How do you anticipate some of the questions, the policy questions, or the experiments that are going to be needed, and how quickly can you change these experiments using this technique that you guys have described?
Right. So the key set of things, as I pointed out, where there is the interaction networks is one of the things that would change if you get better data or newer data on how people would interact. That would change, and disease dynamics would be the other one, which is always changing as you get more and more data. So these are files that you can configure and then run the setup. It would be as simple as changing some parameters over there and running it. Wouldn't cost too much of tweaking about of the model itself.
Yeah.
So we could essentially also, we could even come to a point where we can change the network over time, and it need not be a fixed network. It's not as if there's a fixed network that is that's being modeled throughout. So even that flexibility is there. So.
Right. And how do you guys see this being used in the future? I mean, I see a lot of potential in this tool. Obviously, right now for COVID, this could be incredibly valuable for some of the things that you guys were both mentioning. Ayush was talking about, delaying a second dose, people's behavior based on their understanding of their immunity status. How do we use this tool though? How do you imagine this tool being used in the future, maybe even outside of COVID? Because it seems like there's a lot of potential here for a lot of different applications.
Right. So I touched upon a few of the possible applications. So the first thing would be how does as the economy opens up, we could answer questions specifically about whether what would be the effect of travel, right? So how if as people start traveling, what kind of effects that would you see, and how quickly you need to vaccinate so that the businesses can get back, so that they can get back, and the economy can get back get back on track. So these are business level questions that you can answer. You can also answer questions in the economics domain, really about, because ultimately this is about agents who are acting in aggregate fashion, and that's the net effect of economy. So you can use it to model economics. So these are some of those questions that we think can benefit from doing this this tool. Yeah, using this tool. Yeah,
that's great. You know, I see that a lot of potential in you know, especially in the healthcare space. You know, I'm curious, you know, some of the things like having, you know, vaccine or having, you know, some of the testing. What if we wanted to look at a new element of, you know, COVID? Let's say maybe it was some new aspect, a new test that had been passed by the FDA. How quickly can we update this current model if a new test was to be passed and do an experimentation? Maybe I'll ask Ayush to.
so you want to take that, Ayush?
Sure, I'll do that. Yeah. So basically, we support all of these configurations off the shelf. So to add any of these, for example, to add a new test, you just need to basically input a new configuration file, the way we uploaded the CSV for the disease dynamics. So a test can be a part of that same configuration. You may also use it as part of your population dynamics, and it's just as simple as uploading a file for you. We support the basic infrastructure for doing these interventions. Different instances of or different copies of these interventions may change. For example, we see the granular control for vaccination. It's very straightforward to add that same control for random point of care testing as well. And once we do that, you can try out as many tests as you would like.
So really, you just need the configuration file. You can, the way that you've had it designed, you can upload that configuration file and the model will adapt to that those new parameters.
Yes.
Yes.
Oh, it's very impressive. Well, thank you both. This is brilliant work. I think we are out of time, at least what I was told. So was our kind of finishing timeline here. Any last thoughts about what you're going to do with this model in the near term, in terms of maybe updates or modifications?
I think so. We've already been working on building support for multiple viral variants, which may spread in the society at the same time. And we want to generally also focus on building support that can extend for that can move towards the post facto effects of vaccine distribution. For example, what if the vaccine does not last? What if the vaccine only lasts for 12 months? Or what if it decays in a particular fashion?
Right.
What if people do not come back for a second dose? Like, there'll be a lot of important questions that we need to consider. And those are questions we are ready to support. And we would love for expert clinicians like you to point us to the right questions and use the tool and make it.
Those are critical. Yeah, those are critical questions. And, you know, this allows us to, you know, having a tool like this allowing us to answer these questions is, can't tell you how important that is. I mean, really, you know, to do empiric research just takes too long in these kind of pressure cooker situations that we're in, like right now with COVID. And so having a tool like this really gives us some information that otherwise we wouldn't be able to have. And I just want to thank you both. I mean, this really could impact lives and you know, allow us to make better policy decisions and healthcare decisions. So just want to thank you for your work on this.
Thanks a lot. Yeah, it was it was a very exciting time, and we really look forward to collaborating with experts in framing the questions, and we'll be happy to provide the support. Thank you.
Thank you, Tom, and thank you, Balaji, and thank you, Ayush. So let's transition over to our next section and hear from experts who are already in the field working on various tools for vaccine administration. Chris Joshi from Change Healthcare, Asif Dhar from Deloitte, and Vinay Gidwani from PathCheck, as well as a CIC Healthcare working at the Gillette Stadium. So Chris Joshi.
Thanks, Ramesh, and hello, everyone. Can you all see my slides here?
Not yet.
Good. How about now?
Yeah, that looks good.
Great. So I'm just going to begin with a quick introduction to Change Healthcare for those who don't know who we are. We are a publicly traded company. We connect just about everybody in the US healthcare system. People generally don't know about us because we're usually behind the scenes. So we connect to all the major EHR systems in the hospitals like Epic, Cerner, Meditech, or Athena, you name it. We connect to pharmacies, labs, and all the health plans across the country, both commercial as well as Medicare and Medicaid plans. So in some ways, we are like a utility for the US healthcare system, connecting everybody. So when the vaccine situation came into focus and we realized that there's going to be a fairly short window of time during which we would have to vaccinate a large number of people and manage the data that goes along with it, we asked the simple question, what can we do with all the connectivity that we have and all the transactions, the literally trillions of dollars worth of transactions that flow through our networks? Can we use that network to very quickly stand up capabilities to support the public health agencies, to support the physicians and pharmacists, and try to reduce the administrative workload that they were all about to face? So given the magnitude of the challenge, we felt like whatever solution we came up with had to be really, really simple. So we began with the simple question of what data do we get today? You know, if you want to do something fast, the best way to do it is to rely on existing interfaces, existing infrastructure, existing networks. So that's where we began. Today, we connect to tens of thousands of pharmacies, really hundreds of thousands of physician offices, and we began there. And these folks typically use us today to send data to public health agencies like registries, but they also use us for claims to get reimbursed for whatever healthcare service they provide. So we went to that data source and we asked ourselves, can we create a credential that can verify the administration of a vaccine to someone and simultaneously also help the provider solve another problem, which is getting paid? So since the vaccine is free, the federal government's paying for it, the only thing that a provider needs to do to get paid for the administration is submit a claim to an insurer, whether it's Medicare, Medicaid, or a commercial health plan, to receive what's known as the administration fee. So we thought that we could take advantage of that and create an open standards-based vaccination credential that could verify that that shot actually was given with a way of electronically verifying the passport, as we call it. So rolling the clock forward a little bit, and I'm going to show you a demo in a moment. The design principles that we really tried to adhere to here was, first of all, simplicity. We wanted to make sure this was really simple, and which meant trying to represent the original source of the data. We did not want to create a database in the sky with everybody's information. We instead felt it was more appropriate to have the verification come directly from the provider or from the pharmacy as the source of truth. So we tried to build a model in which we were not an aggregator. We were actually representing, under a business associate agreement, the provider who was actually administering the shot. And that meant that from a privacy perspective, we are trying to be fully HIPAA compliant and try to fully represent the situation that exists today, or the relationship that exists today between the physician and the patient, with no one else really required from a design perspective. We also wanted to make sure that there were no downloads required. We felt that a system that relied on something that everybody knows today how to use, like a text message-based system, would work best. A system which required downloading of apps and setting up of accounts and passwords and all of that would be needlessly complicated. So we tried to design around that. And we also wanted to make sure that there was no new workflow involved. So to the extent that a physician or a pharmacist would do the stuff that they would normally do during administration of a vaccine, we did not want to add any additional workflow or paperwork on top of that burden. So that led us to a fairly simple design that allows us to create a credential that can be electronically generated and delivered via text message to a patient, and which can then be flashed up on a mobile screen and verified by any party that needs to verify that, such as an airline or a school or a work site, et cetera. So without that, and to keep my introduction here short, I'm going to take you straight to a video that our product folks put together, which explains how this works, because we found that even pharmacies and physicians had a hard time understanding conceptually what a passport really means. It was all very theoretical, and until they saw something they could see and touch, it was hard to explain. So here's the video.
As an independent healthcare technology company with one of the country's largest networks, Change Healthcare is ideally suited to offer portable vaccine verification. Our network spans physician offices, hospitals, and pharmacies, enabling us to track and report where and when each vaccine dose is administered. When individuals share this information with their doctors and other healthcare providers, it can help to ensure subsequent dosing, where applicable, is accurate. Vaccine verification can also help to convey protection and ensure safety as our country works to return to normal routines. Introducing Change Healthcare's Vaccine Passport, making it easy for individuals to verify their vaccinated status and share it with others. Here's how it works. Once an individual receives a vaccine, they can text the word passport to COVID or 26843 to get a vaccine passport. After a quick challenge question to verify identity, the individual will receive a mobile web link to access the passport. Click the link and they are ready to go. The vaccine passport includes both the individual's photo and a QR code that, when scanned, will present information confirming their vaccine status. From this home screen, the individual can save the passport app to their phone, share their vaccine status with others, access more information about their vaccination. To save the passport to a phone, the individual clicks the Add to Wallet button appearing on the home screen and follows the prompts. Now the passport is easily accessible anytime it's needed. By clicking the Details button, the individual can share information based on the CDC's COVID-19 vaccination record card, including vaccine type, date each dose was received, where it was administered, and, if applicable, when the next dose is due. Clicking the Share button allows individuals to instantly share their passport with whomever they choose, such as a doctor, work supervisor, or family members. Additionally, they can also share the passport with other apps, such as healthcare apps for Apple iOS and Android, and with ticketing and travel apps. By making it easy for individuals to verify and share their vaccination status, the vaccine passport can help facilitate a smooth return to work, school, and all the activities of daily living. For more information about our vaccine passport, contact us today.
I hope that was helpful, and usually pictures speak louder than words. So I decided to just show you how it looks. I'll just end with a couple of comments, specifically around what we're trying to do to make this sort of easy to adopt. And that goes back to contracting. We would love to be able to tie this into a couponing infrastructure like Ramesh was describing earlier. A scheduling infrastructure. We know a lot of states are struggling with scheduling, especially for the mass vaccination sites that they're trying to put together. And finally, to make sure that any kind of contracting work or business sort of infrastructure that needs to be in place is kept to a minimum so that adoption can happen quickly. With that, I'll hand it back.
Thank you for that, Chris. And I had the pleasure of working with your teams from before holidays. And some of these products already are out there. So people can try them out, which is very, very exciting. One of the earliest efforts in the nation as far as I know.
Yeah.
Excellent. Yeah, look forward to working with you. So I'm delighted to welcome Asif Dhar from Deloitte. And Asif and I have been working together for many years. He leads innovation at Deloitte. Asif.
Sorry, just getting on video. Hello, everybody. Ramesh, MIT team. It's great to have a chance to connect with you all. At Deloitte, we've had this wonderful opportunity of being able to lean in to this national pandemic in a multitude of ways. We have literally thousands of professionals supporting efforts that range from contact tracing, testing, figuring out vaccine and vaccinations, hesitancy, understanding public health communications and the like. And so it's great just to be able to absorb all of the material that I'm hearing today. There are a number of topics that I want to get into. The first is user design, and I'm really happy that we've heard from IDEO today. The importance of being able to go where our users are is important in overcoming a ton of the barriers that we see in place. And I'll give you a couple examples. A number of individuals who we work with and organizations have come to us and have said, hey, you've helped us establish testing competency. How about if those pop up or other competencies we've established, how about we add vaccination to it? And there are a couple things that you learn and the reasons why those topics are really important. The first is that communities themselves need to feel empowered. Some of them may or may not want to be able to travel large distances on public transportation to reach a mass vaccination center. Some will be more than delighted to, but understanding the psychology of the community and the user experience of what they expect is crucial. Some perhaps may prefer analog, like we saw from Chris today. Some may prefer a digital experience. Understanding that psychology is going to be really important for us to overcome the hesitancies here as well. I'd also be remiss if I didn't talk about misinformation channels that have exploded regarding vaccination. And this week alone, and last week, I've been involved in numerous discussions with healthcare and public health leaders who've been trying to tackle this particular topic. And at the end of the day, there are misinformation channels themselves that need to be inoculated. They're very proximal to people. They're close. People use information every day, and expecting us to completely redo all of our information channels and all of our influence and the channels that we rely on may not be possible to do in the time frame that we need to vaccinate the populations here in the US and abroad. So it's really important that we meet our users, like I said, to where they are, provide options for communities vis-a-vis pop-up capacity in terms of vaccination and the sort of technologies that we've seen today. I'll make one last comment. You know, in the US, there's a fairly broad adoption of smartphone technologies that allow for text to QR code or web-based smartphone technologies, et cetera, during the scheduling process and so forth. But we do have to realize that there are populations, even in the US, that need help. And so the analog, the physical card is an interesting idea, but when we get international, that usage scenario is different. And I think we need to think about COVID as an international phenomenon, or COVID-19 as an international phenomenon. Just as in the US, we are thinking rapidly about escape variants that emerge from South Africa, the UK, and obviously, as of today, some people are talking about Brazil. We know it's a global phenomenon. And so it's important for us to think about how do you reach everyone? And there are going to be places that persistent network-oriented capabilities may be challenging. And so providing the alternatives that I think we've seen here today, obviously those that we've been honored to be a part of at Deloitte as well. Many of you guys who are listening to this know about the initiatives that we've already been a part of. But I think the discussion today is really important because, like I said, if we don't reach and meet the end users to where they're at, we're going to accentuate hesitancy, not resolve it. So, of course, I've got a fairly broad series of topics that I can get into, but I wanted to start off with those introductory comments.
Thank you, Asif. And those are some really important comments about vulnerable population, especially as we start thinking about global concept. So it's it's just a fascinating area. I mean, given Deloitte thinks about the full life cycle of many kind of health and health IT solutions, do you think this particular aspect of vaccine rollout will allow us to learn about what we do in the future?
I think we'll certainly not only learn from it, but it's interesting. If you look at our healthcare system, I'll wax philosophically just for a second. You see the emergence of the employer-based health plan benefit as a common practice emerged post-World War II. So, crises create demands in terms of employee retention, and employees start expecting different experiences. For us to get employees comfortable with full return to work, there's going to have to be the expectation that they're in a healthy environment. And the idea that there'll be this sudden shift between working perfectly from home and returning perfectly 100% in society, I think is a silly idea. It's an unrealistic idea. If we had a 1 month transition in terms of an experience, that would be one thing, but something that goes on for a couple of years, it tends to sit and reside in social consciousness in a way that creates permanent change. And so as a result, we'll have to learn from it, because residents and citizens and employees and students and professionals and staff and leaders, everybody will expect it. They will just simply refuse to have to go through environments where they feel like they're bearing disproportionate risk. And so we have to learn from it, because like I said, people will expect it. The other thing is that the social consciousness of public health is pervasive at this point. We see it with the current plans from in the administration today, but even prior to that, the notion that return to work and return to society is tightly interwoven and interlinked with return to health from a public health perspective. So this is not a once and done phenomenon. It would be a catastrophic mistake to expect that to be the case. We're going to go take care of some emergent things and then it'll just go away. I think people will expect more from us than they already are. And that's as nonpartisan a comment as I can make. And certainly my comments about the current administration or past, these aren't partisan comments. These are expectations of consumers and citizens and residents. And so all of the things that we've been talking about, do you have something that travels with you that allows you to get access to your health in a quicker way? I think we're going to see that to be a part and parcel of our experience. And if you look at any of the operating systems on any of our, whether it's smartphones or IoT, it's all the expectation and the base software. So slight changes in terms of how people deploy them, but it now has become an expectation of life and an expectation of the daily technologies we use.
You're on mute.
Thank you, Asif. Very insightful comments there. And on that note, let me invite Vinay Gidwani, a serial health IT entrepreneur, advisor at PathCheck Foundation, somebody who's always my go-to person. He might be the world's expert right now, a top expert in thinking about vaccination workflows, and also an advisor at CIC Health. Vinay Gidwani.
Vinay, you're on mute.
Okay, there you go. Thanks, Ramesh, for the introduction there. So I want to talk a little bit about some of the learnings that we've had at launching a mass vaccination center at Gillette Stadium. So as Ramesh said, I'm an advisor to PathCheck Foundation, but also work very closely with a firm called CIC Health, which has launched the first mass vaccination center here in Massachusetts at Gillette Stadium, where the Patriots play. You might have read some press about it over the last few weeks. The interesting thing, just as a way of background, is that we launched this in less than 4 weeks. So from the moment that the call was made to the Department of Health to want to do such a thing, to actually injecting the first vaccine to somebody was actually less than 4 weeks, which is a pretty amazing feat of contracting and logistics and a whole other things to pull this off. And there's multiple parties that came together to make it happen. So it has been a pretty significant effort. And at this point, we're doing thousands of vaccinations a day. So the Gillette Stadium environment, as you can imagine, is expansive and gives us an opportunity to grow very quickly. And there's a lot of discussion around how to do that. And we are now into our second and a half week of this, and we are doing multiple thousands of people a day, and it's and there's a lot of learnings. One of the things that I think from the last 4 weeks has certainly been that it's one of those things where everybody has a plan, but once you get into battle, you have to throw the plan out the window and reinvent it pretty quickly, and that certainly has happened a few times as we've learned a lot about how to launch these centers. So I think there's a lot to be said about practical on the ground knowledge that comes from this, and lining up against some of the theory and work that's done beforehand. So here's a couple of pictures of what the center looks like. It's actually grown quite a bit from the last time this picture was posted. But as you can see here, there are multiple vaccination centers. There's a lot of signage. There are observation lounges. We're privileged at the Gillette facility to have these massive screens. In fact, I think there's 25 plus televisions that are in eye shot of everybody who's getting vaccinated or getting observed. And that gives us a lot of opportunity to demonstrate, to push out messaging and remind people to do certain things that we'd like them to do. So that's one important sort of lesson, is to think about the captive audience that you have at the time of vaccination and the messaging that you want to give them. So we have a lot of privilege to do that there. You can have an idea here of what it looks like on the ground and all those different screens and how all the vaccination centers are lined up for people to get vaccinated. I want to talk about some of the major learnings, just very briefly, about what we've learned from this experience. The first one is when you think about, if you think about the stack of vaccination experiences that everybody will go through, I think they fit into 3 significant buckets. At the top of it is you have these super pods like Gillette Stadium, or what's going on in Disneyland and other large public sites around the country. Then you have the middle, which is your pharmacies, your primary healthcare facilities, your community clinics. And then you have the bottom, which is mobile clinics going into neighborhoods and reaching as many people as you can, especially those that are in vulnerable population centers that don't have the wherewithal, don't even have a primary care doctor, so they don't even have a clinic to go to, and don't have the wherewithal to take time off work to go to a super pod. I think it's at the top and the bottom of that stack is where the majority of the innovation needs to happen, especially around the digital experience. There's quite a bit of infrastructure in the middle. It's the top and the bottom is where we're doing things that we've never done before. There's never been these sort of super pod types of environments. We've never sent mobile clinics at the number that we need to into neighborhoods to vaccinate people ever in the past, at least in modern times. And so if you look at the infrastructure that exists within healthcare today, that's where the innovation is going to happen. So one thing to think about if you're working in this area is where you can really make a difference in those 2 areas. So that was sort of learning number 1. Learning number 2 is to really think about this as an experience. I think we take for granted the fact that people who desire to get vaccinated, so there is absolutely a public health campaign that has to happen to make sure people understand that this is the right thing to do and it's the safe thing to do. But even if you convince them of that and they are motivated to get vaccinated, it doesn't mean that they'll go through all the necessary hoops we put in front of them to get vaccinated. And if we think of it like a sales funnel, if I have a desire to buy something off of an online shopping website, I actually have to go through an experience that allows me to do that very quickly, or I'll go somewhere else, or I won't do it. And so if we think about the process by which we ask people to schedule appointments or to fill in personal health information or to fill in their own data about themselves in order to get an appointment and then show up, and knowing that they have to show up at a particular date and time and place, all of those are opportunities to lose people through the funnel. And just because they have the motivation to go through the funnel to get vaccinated doesn't mean they'll do that. And we have to continually architect this as if we're designing a sales funnel online, where we want to remove points of friction at every step of the process, both digitally and physically. There will be many people who will attempt to get vaccinated or want to get vaccinated, will miss appointments and just never get back to it. And I sort of think of the last 50 or last 100 million people that get vaccinated in this country will be a long tail of people that we have to try to reach. And one of the factors to make sure we do that as quickly as possible is to make that funnel as efficient as possible. So that's lesson number 2. Lesson number 3 is scheduling is really, really non-trivial. This is a big problem that is happening everywhere in the country. As we talked about earlier, that when appointments become available, they get booked up very quickly. The notion that I have to schedule something and then show up at that particular date and time is not conducive to a large amount of people in this country who work hourly wages, who can't afford to take time off work, who can't afford to get onto public transportation to go somewhere and get vaccinated. They can't afford to make a schedule about anything because they will take whatever work they can to from a career point of view. So making sure that we make scheduling very simple, and in fact, in some cases, remove scheduling altogether, as was proposed earlier, is going to be, I think, a really important learning. Also, second doses, that's a really non-trivial issue. Making sure that people have the second dose schedule available for them. At Gillette, we have a 95% success rate in getting people to schedule their second dose before they leave the site. Which I think is really strong, and we're gonna have to work really hard to keep those numbers high. Fourth one is keep it simple. A lot of us are technologists. We like to throw technology at the problem. Less technology is actually better, because when there's more technology, there's more opportunities for errors. There's more opportunities for breaks in the workflow where friction will exist. And it's better to keep things really simple and remove as much technology. So the idea of these paper cards, I think, matters a lot. The last thing is customer service really matters. If you think about it this way, for millions of Americans, this will be the first time that they go through some formal healthcare experience. We want to make sure that this is important, that we take the time to care for people, to deliver it safely, but with kindness and a smile. That's the only way we're going to get people when they come through the experience to tell their friends and family to also get vaccinated. It can't be highly clinical. That's one thing that we think a lot about at CIC Health is how do we make this an experience that's really awesome? We're opening Fenway Park next week, so you can come get vaccinated at the famous baseball stadium. Also a lot about making sure that experience is a really nice experience. For many people, it's the beginning of the end of COVID for them, and I think that's a really important thing to acknowledge. So I'll pause right there, but I think those are some of the big learnings that we've had about setting up the first mass vaccination center here in Massachusetts.
That's thank you for sharing that, Vinay, especially your last point about the user experience in this case is probably going to decide how, socially it's acceptable to go through this vaccination. It's because it's not just about the jab in the arm, but everything that happens before that and after that. Can you just share? I would like to invite Chris and Asif back on the panel if you can turn on your videos, so we can have a open, frank conversation here. So Vinay, just to start with you, are there things that you have seen that are, like you said, we want to remove technology from this whole workflow? I love how Chris is thinking about an SMS-based system, or the work with MIT and IDEO and PathCheck of just analog vaccination cards. Are you seeing such innovations that could essentially remove technology as a barrier, as opposed to this this obsession that we have, that we think that when you insert technology, things will always get better?
Yeah, I think the SMS-based approaches are really important. If we think about it, right now in Massachusetts, we just announced that we're going to 75 plus starting next week. So if you're 75 years or older, you are eligible to get vaccinated. They don't have smartphones. They're at that cusp where they might have not ever adopted a smartphone. They might still have home phones. So how do we facilitate those people to be able to make appointments where they have a simple piece of technology, or that somebody else is going to be making that appointment for them, such as their adult children, and making it really easy for somebody to represent somebody else? Like, that's an often forgotten use case, is that the vast majority of people who really need a vaccine will be having their schedule made by somebody, or having their appointment made by somebody else. And so just thinking through those digital experiences where that's actually a supported process where people don't have to hack around that, I think is going to be an important thing. But then as I talked about, just simple SMS links that you can pop open on your phone to do something really quickly and pop out of, I think those are going to be really, really useful. If you think about the idea of a mobile clinic showing up on a street corner and telling people around them, hey, if you're walking to the train, if you got an extra 5 minutes, let's get you vaccinated. They don't have 10 minutes to fill out something on their phone. That will take up all the time they have. And that's how long it takes now. So you've got to think through those use cases very differently.
Good. Chris, Asif, any thoughts on effectively how to make it as easy as possible for users, and the difference between stadiums versus pop-ups versus kind of, formal pharmacy or hospitals? Those three seem like very different experiences.
Well, they
Yeah.
do.
Go ahead, Asif.
Well, they do, and your opportunities in each are unique. I love how Vinay talked about Fenway, and that's an opportunity. That's an opportunity in terms of experience. For others that want to go to where they're at physically, there's a comfort in being vaccinated or in a community, and having those community centers being supported, nurtured, blogged about, tweeted about, whatever social platform that people have locally, in order to make it so that it's a community activity. Don't forget that we are influenced by the people that we happen to be influenced by. And so that's crucial in terms of the design experience. And so each of those venues has a unique opportunity. Also, the physical organization of how you set them up is radically different. If you have to drive somewhere, you got to really think about parking. That's not insignificant. If it's public transportation you're talking about, that has to be really thought through very clearly. And finally, if it's walkable, you have to make sure that walking experience is also reasonable. Time, distance, how the lines are set up. And finally, it's cold in part of America right now. And you have to appreciate that if we've got people sitting in the cold for 3 or 4 hours at a time, they may leave.
Totally agree. Wait, one thing to think about is how to push some of these experiences to the edges. So leave people in their cars before they wait in line. Tell them when to leave their home, estimating their time for transportation before they show up too early. Like, these are all things that where if you don't have a lot of people congregating in one place and getting cold and waiting in line, but rather push them out so they can do those in the comfort of their home or car, like that, the logistical movement of people is super important.
Yeah, I couldn't agree more. As you get to the edges, the and becomes more important. The choice becomes more important. Right? We can't assume that everyone's going to do things the same way. And to your point, Vinay, the long tail of the last 50 or 100 million people is going to be hard to get to, because you can't predict what situation they will be in. They might go to Fenway Park, to get their first shot, but a month later they may go to a pharmacy to get the second shot. So the option to go from an electronic to a paper process, or from a paper process to an electronic process and back and forth, is really important. We also found that early when the pandemic hit, we had to actually design from scratch a new solution, which we called virtual front desk. And it's kind of interesting how that happened, because physicians started to tell us that patients didn't want to come in, not because they were afraid of getting infected in the office, but they didn't want to sit in that front office for 30 minutes, which was a typical waiting time before the physician actually saw them. So we had to create a solution where you could enter all your registration information remotely, and then do exactly as you said, sit in the parking lot in your car on the day of the appointment. And you would text the physician that I've arrived and I'm sitting in my car. And when the physician was ready to see you, they would text you back and then you would walk in, right? I mean, that kind of system, you would not even have thought as being relevant, maybe a year ago, but now people will take that for granted. People will not want to stand in line 6 feet apart out in the cold, especially if the line is going to wrap around the pharmacy twice, right? I feel that the more flexibility we can provide people, And the more workflow enablement we can do, and that this is critical because people, especially pharmacists who are busy, physicians are busy, they don't want to have to fill out yet another piece of paper, look into yet another screen. We have to make the technology invisible and make it disappear. And that requires many of the existing players, frankly, to work together. So it's an incredible opportunity for across the industry collaboration, because no single entity, no company, no government agency can do this all by themselves. We have to show that we can all play as a team.
That's fascinating. Switching topic a little bit to vaccine credentials. I know there is kind of a mixed feelings about it, will it lead? Will there be a scenario like some people say that, hey, if you're going to other than airlines, which is kind of an extreme case, in most scenarios, either you have people who are all safe, or there are people who are just have to wear masks and keep social distance, and anything in between. Where some people are vaccinated and they have special rules, may or may not work out. I just want to hear from all of you about how you're seeing that. Is vaccine credentials going to be a thing, or is it going to be used in very niche areas like airlines and so on?
Well, I'll start off with some high-level comments. We have vaccine credentials in the U.S., but they're on paper, broadly speaking. The question is how they're going to be used, and are they digitized, and are they shared, and are places of work, business, entertainment, sports, and travel going to be limited by the behaviors you do or your willingness to undergo a treatment? And that's a more complicated social question that we as a society have to get into. I want to make one comment about the last topic that I'll lean into this. It isn't that technology isn't deployed even in the IDEO example, Ramesh, that you guys went through. Technology obviously is deployed, otherwise how are you going to use a QR code, right? The question is how do you manage the user experience so it's as simple and easy, comfortable as possible? And people have some sense of confidence and agency in the experience. And I think that's what we're solving for as a society right now. I think right now, the most important thing we do is to get as many people vaccinated as possible. So number one, people look around and they're like, well, I didn't see that many people having issues and they're healthy. And there's positive reinforcement in vaccination. Things become popular because your friends and colleagues do it and they have a decent experience. But if your friends and colleagues have miserable experiences and people don't want to do it. So I think that's the thing we're laser focused on. I think a lot of the discussions about the use of information go back into the conversations we've been having forever. Where's your data kept? How is it kept? How is it used? How are certain behaviors going to be rewarded or incentivized therein? It's a social question as much more than it is a technology one.
I would agree. I think having the social comfort with the vaccination process and building a little bit of social peer pressure as well that comes from a positive peer pressure. If you see a lot of people around you vaccinated, you want to be looking forward to getting vaccinated yourself. And if you hear a lot of people being concerned about the process or even being turned off by the inconvenience of the process, others will start to say, you know what, maybe I'll put off my vaccine for a couple of months until it gets easier, right? You don't want that happening. So the initial experience is really important because it'll set the trend, positive or negative, for people. And then as you go through this, your question, Ramesh, was about, the impression people get, the safety or lack thereof they feel from the vaccine. I think the credential in particular is more for the person's own use, right? Over a long term, right? Think of this as a journey from the time of vaccination over the next 6 months, 12 months. It's likely that you'll need a booster shot 9 months from now if the variant, new variant that has significantly mutated, right, is prevailing around that time. You never know. So having a system that is tied to the patient and is free of other inconveniences is important. And for the patient to be able to quickly recall that information and interact with it without the typical barriers that we've erected for the rest of healthcare data. We all know those. Healthcare data today is not easy to interact with. It's all pretty, boxed in and tied down. This is one of those pieces of information that needs to be liberated and actually should be tied to the patient from the get-go.
Fascinating. We're reaching at the top of the hour, so I'm just going to remind everybody about our presentation today. I want to thank Chris, Asif, and Vinay, and I encourage you to stay on for our private session. But for the public session, we want to thank you. And also for vaccine credentials, I wanted to kind of put this diagram from one of our upcoming papers, which is when we think about whether it's the coupons, which you can think of them as gift cards, or think about badges, which are more like health passports, or abilities to upload your health information for reporting to CDC or vSafe. You can think of this kind of offline versus online models. The holder, the user, can be offline, can have intermittent online access, or can be online at the time of interaction. Or the verifier, which could be a coupon verifier, the vaccination site, and so on, can be offline, intermittent online, or online. And the analog cards that MIT and PathCheck and IDEO showed in the first half of the presentation today is kind of at the bottom left. It's like offline, offline. Everybody can be offline. The user just has a paper cred, and the verifier doesn't have to be online. They can verify it with an app that doesn't need to be connected to the internet at that moment, and they can still validate it on the go. And then the bigger bubble is the offline app creds, which is still using this offline credentials that Anna talked about, and can have intermittent access and go forward. And then some of this, as Chris talked about, is you could get an SMS, and at some later point, you might open that link, for example. And then the more traditional credentials that you may have seen for online credential verifications require the user to be online and the verifier also to be online. So they need live access to the internet. So this whole space is actually pretty exciting. And depending on the scenario and depending on kind of the sophistication of the user, you might choose one or the other. And each of them, of course, have their own positives and negatives in terms of trade-off between ease of use versus likeliness of fraud and so on. So I just want to kind of put it out there so we realize that there's a pretty wide design space as we move forward. So I want to thank everyone for joining today. And we talked about paper cards and SMS and apps. Then we heard from our partners at Adobe, MIT, and Mayo Clinic of the Deep ABM, a new way to merge agent-based simulation with graph neural networks for predicting COVID-19 scenarios. We heard from Chris Zoshi from Change Healthcare, Asif Dhar from Deloitte, and Vinay Gidwani from CIC Health on expertise in vaccine administration. So please check our website, pandemic.mit.edu, and also join our Slack at tiny.cc/pathcheck Slack. Thank you, and we'll see you next Tuesday for the MIT conference on vaccine.